Well, thank you all for coming here this evening. We have a group of Woodie Flower finalists here. We're going to start here to my left. I'm going to give some introductions. This is Ryan Cahoon, who is a student as one of the founders of Team 2046 Bare Metal. While attending university in Pittsburgh, Pennsylvania, he mentored FRC Team 1708, Amped Robotics for 6 seasons, working with the software and CAD team. Currently, and for the past 9 years, Ryan has been the lead mentor for Team 766 MA Bears. There's a bear theme going on there.
There is, yeah.
He was honored to be awarded the Woodie Flowers Finalist Award at the 2023 Sacramento Regional earlier this year. At his day job, Ryan develops simulation software for autonomous vehicles at Zoox.
Zoox, yeah.
Zoox. Ryan enjoys working on systems that can eventually run themselves, hence his calling to be an engineer and a teacher. So I asked for a bio for our guest here, and I asked for a piece of trivia for something that might not be known by most people. Ryan took 2 semesters of Scottish dance for credit at university. Next to him, we have Ramon Cuevas, known as Mom by his team 5817 Unirex. He was awarded the Woodie Flowers Finalist Award at the Central Valley Regional in 2022. He has been mentoring and coaching FRC teams for over 10 years and is currently the lead mentor and head coach on Unirex. Professionally, Ramon has been a teacher for 10 years and his major was biology. The piece of trivia is, Ramon became an engineer by accident. Not sure how that happens, so you'll have to talk to him later about that. Steve Harvey is the founding mentor of Team 1678 Citrus Circuits. He started the team in 2004 and was head coach until he retired from teaching in 2021. He continues today as one of the assistant coaches. Prior to teaching math in Davis for over 20 years, Steve was a geotechnical engineer for 17 years. Steve was the recipient of the Woodie Flower Finalist Award at the Sacramento Regional in 2015. Trivia. Steve has a rap video on YouTube called Reindeer Style with over 3 million views.
3 million.
It was 3,000 views, sorry. I actually watched it last night, it's fun.
Is it related to Gangnam Style?
It is based on Gangnam Style.
Okay.
Yes.
David Giandomenico, a 20-year mentor on Team 846, the Funky Monkeys, known as Mr. G, because no one can pronounce Giandomenico. He's known as Mr. G to the kids. David was honored with the Woodie Flowers Finalist Award at the 2017 Salt Lake City Regional. David has a double E background from MIT and UC Berkeley, with a background in high voltage and power semiconductor devices. Trivia. His first job at age 16 was diagnosing and repairing printed circuit boards for cash registers. That job and some loans paid his way through college. Alvin Chang won his Woodie Flowers Finalist Award at the Silicon Valley Regional in 2019. He is an alum from FRC Team 192 GRT Gun Robotics team. Currently, and for the past 17 of his 19 years as a mentor, Alvin has been working with Team 1967, the Janksters, mostly as a mechanical mentor, but also supports tool, equipment, operations, maintenance, and upgrades. Alvin earned his Bachelor of Science in Mechanical Engineering from UC Santa Barbara and works as a senior principal test engineer at BAE Systems. Alvin is also on the board of directors for the Western Regional Robotics Foundation, which hosts workshops and cow games. Trivia. Alvin competed in the very first California Regional at Moffett Field and one of the first off-season events, Rumble at the Rock in Plymouth, Massachusetts. You all probably all know Luann. She's your Senior Regional Director of FIRST Northern California. She won her Woodie Flowers Finalist Award at the Hawaii Regional in 2014. She has been a mentor for 21 years and has spent the majority of that time as lead mentor with Team 3132, Thunder Down Under, from Sydney, Australia. She is also the director of FIRST Australia and was instrumental in its founding. Luann is currently the Impact Award mentor with Team 1678 Citrus Circuits. Luann earned her double E from Carnegie Mellon and has an MBA from Rensselaer Polytechnic Institute. She is a software engineer and has been in the telecom industry for over 25 years. Trivia. Luann loves libraries and has over 40 library cards. in California. So we'll start with some of these questions. I'll just put it out to you, and whoever wants to answer can answer. You know, if we could spend maybe 3 or 4 minutes on a question or an answer, that'd be great. Effective communication is the heart of Woodie Flowers Award. How do you alter your communication style to inspire and motivate students and mentors alike, who may learn or create better with a different communication style? Ryan?
Yeah, good question. I think probably the chief way to modulate communication style is just based off of the experience of the person I'm talking to. I guess fortunately with working with teams, we get to know the people that we're talking to and know where they're starting from, where they come to us, you know, what the background is. And so if I'm talking to a rookie on the student on the team who's, you know, wandered in the door and doesn't, you know, what's going on, but thinks robot looked interesting when they saw them drive by or whatever, talk differently than if I'm talking to a mentor who's been in the, you know, the industry for years. But it's interesting that I think when you have a very beginner, you can start with a very small amount of detail, because if you give them too much, they overwhelm them. And if you give too much detail to a very experienced person, they will feel insulted in some ways. And so I think there's a weird kind of a curve that happens where it's actually kind of the middle of the people, you know, maybe kind of the juniors, seniors on my team, where I give the most detail to because they are still learning a lot, but they can handle all that because they sort of started to develop a sense about how things work.
Awesome, thank you.
I'd say meet your students where they're at as best you can. Don't try to talk over them, don't try to talk beneath them, talk with them, figure out how they can communicate. But every once in a while you'll run into a situation where communication comes at a standstill, because no matter how hard you try as a teacher or a coach, it's hard to find them at. So one thing I like to employ is the use of a translator. So our programmers speak their own language. We found a young lady who kind of understood them and say, okay, you're their manager, translate for me. This is what I need done. It went through her, it got done, and it came back, and we got feedback. Slowly, after a little while, the programmers and I have learned how to discuss and okay, explain something to me as if I'm a little child. And forcing them to learn how to talk to somebody else not at their level has helped. So it's one of those things, it's not only us as the coaches that need to learn how to talk to the students, but it's also the students that need to learn how to talk to coaches. So it's understanding that sometimes a common ground can be found, but sometimes a common ground cannot be found. So use somebody else, just don't quit at trying to communicate.
I found a big difference between first and teaching math. Teaching math, I seem to feel like I'm doing a lot of talking, which I don't really enjoy doing. So I've learned that with first robotics students, it's good to sit back and listen, give them space, give them time, give them the opportunity to show what they can do, and then I kind of respond to that. So it's more rather than trying to be the sage, be the advisor, listen to them, wait for them to ask questions, and then answer those questions.
Yeah, it's really hard to add much to what you guys have said. I think you've really hit it. You've got to find that common ground. You've got to figure out what people respond to, and talk accordingly.
I think a lot of it is covered by, we'll find a lot of times where we'll be asking questions back to get the understanding and make sure that we're on the same page, and then build up upon that.
Yeah, I completely agree with everything that's been said up here. I think these were excellent answers. I would add 2 quick things. First one is I think you have to communicate a little bit differently with girls than with boys. A lot of times with girls, there could be a fair amount of imposter syndrome and the like, and you really need to sometimes be more encouraging to them to make them feel like you really are interested in what they're saying and really encourage them in a different way. The other thing I would highly recommend is a book. It's called Crucial Conversations. If you haven't ever read it, it is life-changing. It talks about communication and how to communicate with different people, especially when the conversations are critical. So if you haven't read it, I would suggest you get it from a library. I can suggest a good one. And just take a read through it. It's a pretty quick read, but it really did change my life and how I communicate.
Thank you.
Can I respond to that?
Yeah.
I was just gonna, your point about talking to different, you talked about genders.
Yes.
And I think it's easy for my brain to generalize along the lines of genders, so but I won't do that. I will state that though there are some kinds of people I've noticed who need a personal relationship first, and then we build into technical from there, and other people, we start with the technical, and by working together with the technical, we move into a personal relationship, and sort of knowing which kind of person you're talking to, I think, can help a lot, especially, and I don't want to characterize, but I think some of those styles, you know, if you've worked with only introverted males and then you started talking to an extroverted female, you may kind of get thrown for a loop because some of those kind of working styles or whatever are very different.
Yeah, and I totally agree. And when I said that, that is a total generalization.
Yeah.
Right? Because there are girls who are not going to behave that way. There are going to be guys who do.
Yeah.
Right? But that was just for example.
Yes.
Right?
Yeah,
Think about
absolutely.
your audience.
To jump on those students, like being able to be flexible and code switching with students is also a skill that it takes a while to build, but it's like you'll talk to one student one way, another student a completely different way.
Yeah, and I want to go back to one other thing you said, which is I believe it's always about that relationship.
Yep.
Yeah.
Right? That relationship is key. And sometimes you build it in a technical conversation, and sometimes you don't. And learning how to read the student to know how to make that happen, I think is key to what you said.
Staying on this little theme of communication, one of the judging criteria for Woodie Flowers is inspiration to use problem-solving skills. What is one of your best methods to communicate and teach critical thinking and problem-solving skills?
Get out of the way. Don't solve the problem for them. Step back, let them step in it several times. Just do it in the most safest way possible. And then smile afterwards until they get angry at you. And be like, okay, here's how I do it. They'll still get angry nonetheless because they're teenagers. But just get out of the way, let them solve the problem, give them little tips and tricks, and slowly they'll start working their way there. It's a building process. We have these kids for, I don't know about you guys, but for 4 years, and you're going to take them from someone who doesn't know anything about robotics to someone who's hopefully going to do something with the skills that you've given them. And if they don't, at least they had fun along the way. But the big thing is just don't make it about ourselves as the adults, make it all about the kids.
I sort of feel that I often find that the kids need a lot more guidance. They don't know how to break down a problem, and they require a lot more guidance on, for example, finding the problem statement and breaking down the problem into pieces. And I don't find that they can do that in general on their own. That's something, as engineers, you learn how to break something down. It's not intuitive. And I find that I spend a lot of time giving them that individual instruction.
We do the same thing, but in the form of a question a lot. It's like, well, what do you think this piece is doing? Or, well, why is there no light on if you're trying to troubleshoot if a speed controller's not working? Why is there no light on? Or is that a normal color pattern? That kind of helps drive the questioning process. And
How about you guys? We, for our programmers a couple years back, we implemented the Google corner. Well, why is this not doing it? Go to the corner. Go pull out Google and they start researching the problem. Like I said, break it down into chunks, right? This is too big of a problem. Look at this. Go Google this. Go Google that, right? So it's not that, like you were saying, we're not the ones that know everything. Getting them to the idea that you guys know stuff too.
Oh, no.
And build that up.
Absolutely.
Do you think there's a part of that which is you can bound the complexity of the problem from the top by helping them break it down, or you can bound the complexity from the bottom by sort of giving them modular pieces to fit together. We've seen a lot in the first community come up recently with off-the-shelf parts becoming more available, and more complex. And so it's not just you're buying a gear off the shelf, but you could buy a whole shooter off the shelf. And so, whether that's a good thing or not is a whole other conversation. But I think by providing more sort of tools and resources that the students can use to sort of pattern match against, it helps to simplify problems as well that way.
Steve and Wayne, any comments, further comments?
What they said.
Ditto. Steve?
I'm good.
Gracious professionalism is the phrase coined by Dr. Woodie Flowers. I'm pretty sure it's in the ethos you guys believe and live by. What do you do on your team that ensures GP is forefront in the culture of your team?
We always make a big point before, especially going to competitions, that you know, we are representing citrus circuits. Everyone on the team is representing citrus circuits. People know who we are. And so it's ultra important that everything you do, whether people are watching or not, is professional, gracious. So it's really just a matter of personal conduct, being kind to people, being a good listener. We insist that students that come to competition make friends with other students. And we started programs such as Sisters Service, which, you know, we think are demonstrative of gracious professionalism. So that kind of gets embedded in the team when you practice it day to day.
David?
Well, I guess a lot of that as well. We also have similar sort of programs. For example, in providing workshops, I think that the kids have to take it from the other side. You know, they learn what it's like to be a teacher, at the same time, you know, learning how to teach, how to help their peers out, and that carries over to when they're at events. If they can help somebody out, then they have the experience and confidence to do that.
Agreed. We do similar kinds of, I think it starts within the team.
Mm-hmm.
So when students first join, then they're seeing what the older students or the veteran students are doing and learning from that example. Is the teacher-student kind of relationship, like you mentioned.
Right.
And so when they, naturally, hopefully when they encounter people from outside the team, then they've already got it into their head that when I'm with my robotics team, this is how I behave. I behave respectfully and professionally.
So we were in a slightly different situation, right? On 3132, we were the first team on the continent. People had no idea what FIRST really was. And so we, 3132 took it to heart that we wanted to be the team that was known for GP. We didn't really care if we built good robots or not. That would come, right? But we felt like if we didn't infuse that in the culture to start with, it never would be that way in Australia. And so we spent a lot of time, they still do, really trying to be ambassadors for FIRST, ambassadors for FRC, not only in the FIRST community, but around the country and around Asia Pacific. So there's a lot of time and energy spent on how do we create things that's going to promote FIRST, because that's part of being GP, as well as doing it in a really gracious and kind way. So things like the Compass Alliance came about because of that, and just trying to figure out ways to sort of spread the knowledge amongst the entire country.
I got a slightly different view on this one. My students know that at competition we're going to be gracious. That's expected. That's level here. But in our shop, we welcome anybody else in. We jokingly say we take the top 100% of students that walk in. The ones that stay are the ones that are on the team. But come on in, and if a student says it's not for them, we say, all right, thanks for coming in and coming down. We also allow a small valve for them that after 7 p.m. you can get weird. The way we act in our shop with ourselves, there's a lot of ribbing and talking and just letting them be teenagers and still be kids. And then they understand, like, okay, we leave that at the shop. We're outside of the shop now, right? We display ourselves. We all dress the same. We all always try to help out no matter where we can, where we are, where we can be. We share what we got, even if it's not a lot. And it's that idea of like, all right, this is yours. Again, getting the idea of getting out of the way as an adult, right? This is not my team. This is your team. How are you going to run it? How do you want to be seen? And that does help quite a bit.
I think there are ways to provide a relief valve and still set boundaries. So like I tell my students, you can swear at the machines, but don't swear at each other. And we let them, so it sends a signal to them like, this is not your like high school class. This is not, you're going to get wrapped on the knuckles for using bad words or whatever. But the important part is how you are actually treating each other. It's not just about, using the bad word or whatever.
I think I'm kind of fortunate in the school, in the sense that the school already has a very strong service operation in place. But one thing we do push a lot of is for the veterans to work a lot with the rookies and bring them up. And part of that, establishing that relationship is to do so, to be successful, I think, in a gracious manner. So I think that built up pretty naturally.
Do y'all think this helps continue outside of robotics?
Yeah.
Yeah.
I mean, because I've heard, we do this in the shop, at the competitions, but that's some small little segment of their life.
So, whenever we go out, I am always hanging in the back. I don't like to be the face of anything. My job as the head coach is to dole out congratulations and accept blame, right? So whenever we do that, we always have the kids go out and talk, right? And we're always getting feedback that the kids are really great at doing stuff and showing the skills that we're giving them. So displaying what we expect from them, like, hey, bringing them in, like, all right, you messed up a little bit here, but let's do better next time, gives them the opportunities. And also, teenagers are going to mess up, so giving them a safe place, a safe outlet to let them happen and interact with adults. I don't know about you guys, but I'm always surprised when an adult comes to talk to another adult and is surprised that a teenager can talk to them. It's like, well, what do you expect? They're trying to be adults, right? We got to give them that opportunity.
I want to say one other thing that kind of relates to this, but it's a little bit different, which is now that Woody is gone, I think it's up to all of us, everybody sitting here, to make sure that gracious professionalism stays in the program and stays a core tenet. So I'm going to put my other hat, I should take this hat off and put my other hat on, which is, as part of First California, I almost said First Australia, as part of First California, if you have ideas of things that we should be doing or that we could be doing to encourage people to continue to promote gracious professionalism, please never hesitate to get in touch with me or Janet, because we are always looking for new and different ways to make sure that this stays alive and well in the program.
Thank you. Little change of direction here. How does your team approach match and tournament strategy? Who directs the strategy and drive coaching?
So, we try to give the students as many opportunities within the competition as possible. So it's one of those things where when we were making a decision whether we'd have student drive coach versus an adult drive coach, it gives the student more opportunity. So we're a little while ago make the decision to only have student drive coach. Whether I think the focus is not that success and what the students learn are mutually exclusive, but certainly that decision does drive some of that the results of how the match play goes. In terms of strategy, because of having the students take that role, I know personally I stay pretty much far from it. I just watch matches and offer input at the end. Although we have a new coach that's more involved in that too, so he's going to be able to offer the students more direct and more valued input into that scenario. But still, we're letting the students make those decisions so that, I've had a student where she's 5 foot tall, having to have that conversation talking to an adult, trying to convince a drive coach from another team who's an adult, to take the route that she believes is more valuable. Those are really life experiences that you might not necessarily come across except in this kind of environment. So it's, personally, I really value that type of situation to where we're able to put the students and to have them get that life experience and have those conversations. It's hard. I had a student this morning came back, this morning, they were trying to do a field comms check, and they came back, and it's like, we're told there's no comms check this morning. It's like, well, who told you that? It's like, I don't know, someone official with a beard. It's like, It's like, well, go question it. You can have those conversations, be comfortable trying to get them to be comfortable having those conversations. And I know I'm kind of deviating a little bit, but these are the scenarios that we're able to put them into to kind of learn from it, which I think is very valuable.
I don't know.
Okay.
So we do have, sorry.
I don't know. Look, I was
Well,
not part of the team,
Okay.
and we delegate to our other mentors and to our students. And I know some years there were student drive coaches, some years there were adult drive coaches, but I can't really tell you much more because it wasn't my thing.
We have a mentor as a drive coach, but we involve students in a different way. We have a strategy sub-team that is led by a student, and there are mentors involved with that sub-team, so they're guiding the students, and they spend the whole off-season analyzing games. And as soon as we get the new game, they spend the whole build season analyzing the new game. They're looking at all the matches that are being played, they're getting data, they're getting scoring, they're coming up with the scoring mechanisms, and they're developing in-match strategies that we can use. And then those are implemented in competition. We have a strategist, student strategist that goes around and talks to the teams before matches. And she feeds that information to our drive coach. So our adult drive coach, he's just there during the match, but he doesn't get involved in the whole strategizing prior to that.
It's pretty much the same. Usually I talk to my driver, who is also on strategy, and the co-driver a minute before the game starts. All right, what are we doing? And they've taken on the whole role of talking to the other students, talking to the drive coaches to figure out what to do. Also, kind of jumping on your shorties thing, I love all our shorties, right? Short little gals, short little guys. There's a lot of personality in a very small package, and it's fantastic. And we like to encourage our shorties.
I think that there's a line at some point, whether for example, right now we have the students driving and operating the robot, whether or not, I personally prefer that the students be coaching as well. And basically all the activity on the field be solely by the students. But I understand, it's a line, and it's, you could draw it in different places. But I think it's well within their wheelhouse to serve as coaches and determine their relationships, define their relationships with the other alliance partners. And I think it's frankly, to have adults in that coaching role, especially if it's uneven among the alliances. It's a place where, as veteran teams, have a big advantage, because if they've got a coach who's been there year over year, they know they know everything that's happening, and it puts it at a disadvantage, especially the younger teams who don't have that long time experience. So, my personal opinion is that everything on the field should be students.
Similar to Alvin, for me, in terms of we decided that for our team, the best fit was to have a student coach. But I will say the kind of general policy for our interaction between mentors and students is the mentors are there for a reason. Like, they are there to bring all their experience. And so I tell my mentors, you should have an opinion. Don't feel shy about having an opinion, about sharing it with the students, but you do need to have in your mind the idea that at some point you need to stop. You've said your piece. The students can take that information and do with it what they want to, but so your job is to have an opinion, but not to force that opinion, basically. And we see the same thing with the drive coaching, that we have mentors who are offering input about, hey, we saw this in the last match. Remember what we talked about, before about strategy. Here's some ideas about what to do better, but then at some point step back and let the drive team, all the students, play the match that they want to.
Thank you. First is heavily centered to the science, math, and engineering concepts. We all know that a robust business plan is needed. How does your team maintain financial sustainability?
Hopes, dreams, wishes. We reach out to our community. We work very tightly with our school district. We've been very fortunate to have a good, supportive school district for us. But other than that, fundraisers, And anything else? Grants? How about you guys?
We were pretty much solely looking for sponsorships, especially from employers of our parents, or from the grants that are provided through indirectly through, well, maybe directly through First. And we don't get any funding from the school. We ask for a donation from the students here in California. You can't ask for a member fee. So we keep it low at $50 for new members and $150 for returning. And combination of corporate sponsorship and that money keeps us going.
We-
I'm sorry.
Well, we've done a couple of things I think that have enhanced the sponsorship that we've had from like our regular sponsors, industry sponsors, the school district. We've started RoboCamps, which is a summer program, and we're lucky to be in an affluent area, so I think our RoboCamps have been very successful, but we're generating about a third of our income from RoboCamps at this point. And then we also have been very communicative with our parents about the cost of the program and the kind of stuff that kids are getting out of the program. So we actually asked for donations from our parents, and they've been very generous too. So another probably third of our budget comes from our parents, or maybe a little less than a third.
I think similarly, a lot of corporate fundraising, but also some side ones like the school have lockers, so sell locker shelves, organizers. So the kids actually made them out of the CNC router, and they fit into the school lockers, and then we sell them every season. And then when we worked, well, before COVID, we were doing FL events during like the snack bars and stuff, concessions, that type of thing.
Similar parent donations, corporate sponsorships. We're trying to get better at moving out of the like first specific grants into other sources of funding. So I enjoyed going to the Bird Brains presentation earlier today about that kind of thing. But it's kind of a new thing for us to be venturing outside of the safe wall chart of first grants, even though we're kind of necessary. But yeah, it takes a lot. We're 766 is growing. We had 60 people in the shop earlier this fall, which is a new high for us, and we feed the team a meal if we're there during either dinner time or lunchtime, and so that's a lot of resources just go to feeding the team during meetings that way. So it's a lot to handle.
Actually, that brings up an interesting thing. Different teams have different models for how people get fed, and are parents providing the food, or is it team funding buying food and parents are going to go pick it up? Do they get reimbursed, basically?
Yeah, it's something that's transitioning because for the longest time it was parent donations, which was feasible when the team was 25 students, kind of, but now that we're over double that, we're like, okay, can we have two families bring food on a day? But it's getting logistically very challenging. So it feels like we're going to end up going to the kind of reimbursement route, just to have a way to spread the costs more evenly across everyone in the team. So even if they end up paying similar amounts, it's not, you don't have to like drop it all at once on a single day to provide a meal for the whole team. But yeah, so I don't have a complete answer, but it's something we're trying to figure out, especially for larger groups. I'd be interested to hear if any of y'all.
We started a boosters because we'd have parents bring in, because we meet on Fridays and Saturdays. We feed our students dinner for those both days. We started a boosters just to help organize that, and instead of asking parents to donate to the team, we asked them to donate a meal. And the thing I liked about that is our students' palates have increased, because like, oh, what's this? I don't want to eat it. And they start realizing, oh, I like this food, and I like that food, not just pizza every day. So yeah, that's kind of nice too. And also every once in a while, like for our drive team, we got here early yesterday, so we went to Korean barbecue last night and walked in, waddled out.
Rolled it.
Oh, yeah, we're still dealing with it. But food is one of those nice things about a team, that it helps unite the team. We all eat together, we all talk while we eat. They have fun, they discuss, and like at a certain time, like, you be the adult, like, all right guys, good job. clean up and let's go, let's get back to it, right? So it does help with team cohesion to like share meals and even new meals especially too.
Actually, you bring up a good point about eating together.
Yeah.
As growing up, we always ate together, and it's great. So as a point, we stop work, we shut down all the shops. Nobody can be in there and force everybody to come and eat. And initially, there's a fair amount of resistance. People want to get their work done, but it's really important to take that time and socialize. And around all the different kinds of food that you get, that people bring in, that works out very well. It turns out to be very important in terms of making the group more like a family.
So we did a similar thing. We would have parents bring in food mainly on Friday evenings, but while the team was eating, we also would play Fun Fridays. It was our way of trying to get everyone on the team up to speed with everything that had been done in the past, sort of the legacy of the team. We would play Jeopardy, or we would play Wheel of Fortune. We would put together fun games that the team could play while we were sharing a meal. We also had time just to socialize.
You're speaking as the 31-32 mentor.
I'm speaking as the
Not the
31-32. Yeah, everything
we
I've
don't
said.
do Fun Friday.
I know. I'm speaking
Not
just
that
as
we
a
shouldn't.
31-32 mentor, telling you what we did there. But the other thing we found on 31-32, and I will preface it that way, is we made sure that when those parents came in, we made sure that we got them into the lab as well, because a lot of parents, it was almost like a drop-off program. A lot of parents had no idea what their kids were even doing. And if we could get them in to see the robot and do a little something while they were there, we found that they were much more likely to come along and potentially become a mentor, or get more involved with the team. So it was more than just them dropping stuff off. It was also our way of trying to bring them in closer and get them to be a bigger part of it.
Yeah, I'll jump on that too, because we found very early on, if you knocked on doors, you could get small amounts of money maybe, but if you could bring the sponsors over to your shop or to a competition, right, then people see the true excitement and what the kids are really learning, and then it's often easier to get the funding.
Yeah, and even like 31-32 was playing here, our parents would have been bringing food here, but then they've been in watching the matches for a little while as well. Because they would have most of them have no idea what their kids are doing. It's this weird robot thing that they do, and we drop them off and we pick them up. So.
I got a question for you guys actually, because I've been struggling for 10 years how to concisely explain to a new parent what is robotics. Because I try to explain to them, it takes like a few minutes, and the best thing I tell them, like you said, come watch. It's hard to explain everything that happens and what's happening, why it's happening. As soon as you walk in there, like it's especially, I love the first reaction of, why are they cheering for each other? It's like, well, they're your competition, but they're also your help as well. And the idea, like, because they go to football games, right? Oh, we're gonna beat you, we're gonna break his bones, whatever. And here it's like, oh, you're broken? Oh, let's help you fix, right? And trying to get that idea across to new parents has always been an uphill struggle. So I want to how do you guys, what's your sales pitch for them?
Bring some food to the event for the team.
Yeah.
I always compare first to my engineering career. On my engineering career, we had projects, and they were kind of monotonous projects. They were projects that had been done before. We kind of knew the routine, we went through the routine, we solved the problems, the small problems along the way. But I wasn't invigorated by that. First, puts this big problem out in front of students and says you got 6 weeks to solve it. And then you've got all the tools and resources to help solve it. And it puts students in this amazing position. I was never in that position as an engineer, so that's how I describe it to parents. It's just a mind-blowing experience.
I think just showing them bring them to the shop, as you've mentioned, seeing the machines, it's just a tremendous eye-opener for them. And that usually gets us a number of parents who become regulars. It doesn't make the mentors though. Well, we've got a special project on that. I don't know if I've got time to talk about that or not.
So we have one parent that became a mentor.
Okay.
Yeah, we have.
You have time?
Yeah.
Okay, so we're trying a new project this year. At the end of last year, we struggled getting mentors. We've got a lot of interested parents, but we don't have, but they stand on the edges and they see the kids doing these amazing things and they don't really feel like they can contribute. And maybe they stay in that capacity, maybe they just drift off. So what we did this last year, the students decided, let's figure out, let's build another team's robot from a CAD model, but let's have the parents build it. And so we did. You know, we went through a number of the students went through a number of potential machines, and together with the parents, they picked out one that they wanted to build. And they struggled with that for, you know, since June of last year, trying to put this thing together. And it's been, you know, it's been a revelation for them every step of the way. Difficult machining, ordering the parts. In the end, and thinking that when they finished all the machining, that they were done. And spending more weeks, you know, not making our deadlines, missing 2 competitions, okay, and this being the very last competition that they could do it. And they've been working their butts off. But they still couldn't do it. The students had to step in. They had to wire the whole robot. They had to do all the software, okay? And I think it's been a real, you know, now they're watching that robot out there, and it's like, you know, that's their robot. And I know that we've got them hooked to help out. You know, now they know how to machine. Now they know what this competition is really about. So I think it's been a really successful project.
I think to explain to a parent, I don't think it's not as critical like why they're cheering for each other. I think it's more critical of, you know, this is a program that at this point, you know, have alums that have gone through and have, you know, never even going in, never realizing engineering or STEM isn't really even an option or a career choice, to becoming now, you know, now we're 15, 20 years in, you know, many examples of professional engineers working in whichever industry or whatever company. And even if they don't pursue that, they be able to pick up those life skills to, you know, have that communication, talk to one another. I think that's probably from a parent perspective a bigger selling point than, you know, from a long-term perspective what they're doing now.
So I worked at Macquarie University down in Sydney, and we were the home of First Australia. So we had the ability to do some research. And so we tracked the grades of students who had done FIRST that went through our engineering program versus the students who had not done FIRST. And what the data showed us was that on average, a student was going to do 1 letter grade better than their peer group in every single class that they took. So as freshmen and sophomores, you might attribute that to some of the technical skills that they picked up in FIRST, but it wasn't just in those classes, it was across the board. So we did the next step, and we talked to these kids to get their opinion as to why they were doing better. It came down to 2 things. They knew teamwork, and the most important thing was they had better time management. Okay? But that information right there was enough to talk to parents when they would come in to say, do you want to know why your student should get involved with this? Here's some data. And I don't believe that was, you know, just in Sydney. I think that's across the world, right? You could say that, and then we would do exactly what you did and say, and you know, we've had students on the team who, you know, they've gone on and they're working as Google engineers or Waymo engineers or whatever it was, right? And that was really powerful as well.
My only comment to that is the grades during built season probably get before maybe averaging out, you know, the rest of the year.
So this was,
my grades fell when I was in built season.
This was not in high school. This was at university.
Ah, okay, fair enough.
This was their grades at uni.
Got it.
Cool. We touched upon this a little bit about the turnover. How do you keep your mentors motivated? How do you prevent burnout from the of the mentors?
I know me personally, I live in burnout constantly. I teach 5 different courses throughout the day and then go do robotics. So I would love to hear what you guys think, because I'm always toasted.
Honestly, we've all drank the Kool-Aid. I don't, you know. I don't think, I think the problem, the hard part is, balancing life for especially, it depends on which, where the mentors are coming from. You have college students, balancing, your studies versus mentoring versus parents, I think their motivation with kids on the team, although we've been pretty successful with having parents that have stayed with the team after their students have graduated. I think the main thing is kind of, again, they see the end results of, students going from the growth of the students over time, and I think that's the biggest motivator. I don't know if it necessarily cures burnout, but it helps certainly to see that growth and transition over time, the gain in confidence, etc.
I think part of it is you have to keep it fun, right? If you're having fun, if your mentors are having a good time, they are not going to burn out nearly as fast, whether they feel like it's a drag every single time they have to go into the lab. So don't take yourself too seriously. Don't take your team too seriously. You're going to have successes. You're going to have failures, but you can have fun either way.
I think that's true, but I think it's also important to have a well-managed team.
Totally agree.
If a mentor joins a team that's disorganized and not very functional, burnout is going to happen really quickly. But if you join a team that's well organized, the students know what they're doing. We have a peer-to-peer program, so the seniors are teaching the juniors and sophomores, and so that's self-perpetuating. And I think all of that helps keep mentors motivated because they're not constantly fighting the uphill battle.
Totally agree.
There's a flow that they can sort of join in with and be part of.
I guess, so I've seen recently a tick up in the size of the mentor corps in 766, and I've been trying to figure out what exactly happened. And the two things that I've picked out so far is we've tried to focus on having the mentors have their own culture. So we've started doing, like on a monthly basis, dinners with just the mentors outside of the team meetings, because I think it's really easy it was easy for me to just be like, okay, well the team exists in the lab when all the students are there, and the mentors would come, support the students, and then leave. And so I think it was important to have something exist to say, hey, there are other people here going through the same things that I have a chance just to talk as people, but also maybe to talk about sort of what's going on, how I can be a better mentor, that kind of a thing. The second thing was 766 errs more towards the student-driven, student-led kind of side of things. And so there was maybe a tendency to say, if the students got it handled and the mentors are standing on the sides, I think similar to what you're seeing. And so kind of opening up the idea of having mentor projects, echoing a lot of what you talked about the parent bought over the summer. But I've been trying to encourage them to say, look further ahead. Like what's the team going to need next? What are those next big technologies that maybe we wouldn't get to this year even if we wanted to? So we're not taking experiences back from the students or anything. But what can we start building now to offer to the students as new technologies? And you can be the first one to explore this awesome new space, and maybe things are too advanced if we try to do it directly with the students, but then you have a chance to kind of get your technical hands dirty and work on something, be there to support the students when they need it, and then sort of have a self-reinforcing system there. I've been trying to figure out how to do that with the business mentors. I haven't figured out yet what a mentor project in business looks like, so if you have ideas, talk to me.
I think you also maybe mentioned a particular point that this program isn't all students, that there's a lot where mentors can, for example, explore new technology.
Yeah.
And as long as you are bringing students along with it, that's what the program is about.
Yeah.
That's all.
So I think you guys have all learned at least some little tidbit that might improve your team, better your team, little changes to your team. Do you have a question for the panelists? Nobody has a question.
Stare at them harder.
You got to pause
That's the
at
end of the
least
day.
10 seconds. We were taught as teachers. Give them at least 10 seconds before you say no.
What questions do you have?
Are we going to see a Scottish dance routine or anything? Or?
Absolutely.
Not at the end of the day. Talk to me tomorrow morning.
So I have another question then. Dean Kamen famously said, in part, We use robots to build kids. What does that mean to your team, and how does your culture reflect that, your team culture?
We do a play on that. The mentors kind of have our own mission statement that we don't build robots, we build the kids that build the robots. So it's kind of a play off of that one here. So I try to keep my mentors as hands-off as possible. Because again, it's not about us. We get to play with the cool toys when the kids aren't playing with them. But it's not only, because we're using the robot as a vehicle to teach many other things. Like there's so much about robotics that has nothing to do with robots. Like you said, what you guys were talking about is the soft skills, how to talk to people, how to deal with big emotions when it happens, how to work with someone that you do not like, but still get something done, how to handle failures. I think I've had more emotional eruptions when a kid failed at something because they thought we were going to yell at them. It's like, no, fix it, let's go, and let's move on, and how to roll with mistakes. So in building the students, as long as you invest more into them than into the robot will take care of itself, and so will the team.
Yeah. We invested very early on in the idea that we should give our students roles that are traditionally served by adults. So for example, in a typical educational program, the teacher might be the one that's actually doing all the logistical stuff, organizing all the events, the food, etc. But our students are actually the ones that do that. The students are working on Slack, they're communicating with each other, they're setting the agenda, they set the agenda for our sub-team meetings, they set the agenda for our main team meetings. And then there's even some maybe slightly controversial ones like room checks in hotels. We decided that actually we should let a student captain do the room checks. And it was a little bit controversial with our school district, but that really empowered our students. And I think it sets that tone that, you know, we're not putting tape on the doors because we want to make sure that you stay in your rooms. We're actually entrusting you to be adults and behave correctly.
Your original question was, well, go ahead, repeat that for me.
We use robots to build kids. What does that mean to your team, and how does your team culture reflect that?
Well, I think that I've got to remind the kids, even remind myself, that this activity isn't about robots per se. It's about problem solving, and that problem solving is over a wide breadth of activities. And so we do a lot of effort to draw in students from all other disciplines. We've done a lot of, for example, 3D animations. And the idea there is that there's a lot of technology in these activities, in animation, graphic arts. We've drawn people in producing newsletters and photojournals, and all of that stuff gets people in that wouldn't normally be jumping into robotics. And yet, when they see this activity, they've got one foot in the door. We had one student, again, really into artwork. Now, she's designing rockets, literally. And it's great to be able to bring in somebody on the periphery and let them explore all the things in science and technology, not specifically robotics, but science and technology.
STEAM.
Yep.
Throw art in there.
So, after the team meetings, usually the mentors hang back and, have conversations. And I find that probably like 80% of this conversation isn't so much about how the technical issues or how the, robot, certainly there's some of that. But a lot of our conversations is recognizing, what the students need to develop, or recognizing the change over time. So I think that's certainly one aspect where the focus is definitely, from the mentor's perspective, is on the students and not so much on the robot. The students can figure out the robot. We're just offering guidance when the situation comes up. But for the most part, our focus as mentors is really figuring out getting the students the tools they need to keep going, to moving forward.
In 31, 32, I think the culture was, we really wanted to inspire our students to go and have a positive influence on the world. Sometimes that was with technology, sometimes it wasn't with technology. But I think the culture there really was about looking at the students who were there and making sure that they had the opportunity to feel like they were making a positive influence on the world in some way.
Absolutely.
And it's still developing, those problem-solving skills.
Absolutely.
In other words, it's not robotics per se.
No.
It's problem-solving in any discipline.
Absolutely.
Communication, interpersonal collaboration,
Absolutely.
all that.
Where we started this evening.
Mm-hmm.
Last chance, any questions? I gotta count to 10.
Ooh.
A quick one?
Got one over there, two.
Oh, awesome. Yes.
With so many options for STEM programs, like let's say VEX or even like FTC, what do you think about FRC is so unique that you would, like, I mean, you guys are mentors of your own teams. Why would you recommend that to students over everything else?
Well, that's pretty easy. It's such a different level than assembling, for example, parts. To be able to be making things from the basic, from raw metal, basically. It's also the size of the team. It's so many science projects encourage independent work, and that's great. But it's so much more engaging to be able to work in science and technology as a team. And I think this big robotics program where you have 20 or 30 or 50 or more students all working toward this one item. It's just exciting to see everybody learning to work together to make this one thing happen.
Agreed. I phrased it once as, I like this program because when we start off, the students look at the robots we built and say, literally, that is impossible. I do not understand how that could happen, how we could make that happen. And then by the end, 3 months later, they've done it, right? So having that kind of I don't belong here, the imposter syndrome thing, all the way to, I know what I'm doing, we did that, wow. It's that scale, I agree, it's important. I think the other big thing, especially compared to VEX and some of the other programs, is the gracious professionalism that was talked about before. I have not been to a VEX competition, but I've talked to many people who have, and have then also been to FIRST, and they say, even compared to equivalent programs like the VRC versus FTC, there is not that same culture of helping out the team next to you, that kind of a thing. And so just the community, I think, is a big part of what brings it back. The fact that we can sit here and have conversations like this and be admiring each other's work and not feel like we have to be sort of one-upping each other or anything like that. I think that community, which is, I give Woody a lot of credit for, but obviously has been built and sustained by all of us, is I think, the big unique thing that FIRST offers.
I just want to add on one thing to what you said, which is, and Woody actually said it best, people like a really hard problem, right? I mean, the satisfaction you get from solving a really hard problem, there's not much else like it. And that's why I think FRC is great.
I'd say FRC robots look cooler. they're just nicer. There's something more impressive about a 150-pound robot barreling towards you versus a 8-pound robot just towards you, right? Plus, the other thing is, like, I love doing this. We go talk to sponsors and we're like, oh yeah, here's a robot. How long would that take you? Oh, 6 weeks. And professional engineers just start laughing. It's like, that would take us 6 months at least. And then they realize what these kids actually do. So it looks cooler, it's flashier. We build big robots. They do fun stuff. Versus, here's a kit, put it together.
I also think the opportunity to do outreach, because it's such a big part of most FIRST programs, is really inspirational. And we have, going back to what inspires kids, I mean, some kids are inspired by the robot. They are very competitive, they want to build the best robot they can. And then there's other kids, they're not so competitive, but they're much more inspired by helping other teams or other people in the community. So they gravitate towards outreach. And we had a student back in 2014 who looked at our meager outreach programs back then and said, why don't we have like sub-team leads for each outreach program? And I can start all these new outreach, and she started all these different outreach programs that we now have. And it was student inspiration, you know. So I think that is a big part of it. It's the outreach.
Question up in the back
There's
there.
one more question in the back there.
Yeah, you guys previously spoke about the importance of keeping mentors motivated in the teams. So in your personal experience, what keeps you guys motivated?
The money. Oh, I'm sorry. You wanted a serious answer. One of my sayings, and I have a lot of quibautisms, my teams know this, is growing old is mandatory, growing up is optional. I don't know about you guys, but being around teenagers helps me feel young, even when my knee doesn't want to make me feel young. It's fun to hang around kids, right? It's fun to watch them grow over 4 years. It's a little bittersweet to help them learn all these skills just to see them go away. But when they come back, it's like really rewarding.
Mm-hmm. Yeah, it's a lot of fun working with all you guys. And on top of that, different than say a classroom, you're working with students who really want to be there. And then further, you know, the problem is changing every year. If we had to build the same robot, if it was BattleBots, that wouldn't be so engaging. And then again, the technology keeps changing. You know, we're getting all these fancy motors and controllers. And so that also keeps me engaged.
You get to play with cool new toys.
That's right. Yeah.
I'm
The machinery changing, you know. The PC revolution happened in the 80s, but now you can have a CNC in your garage. It's pretty amazing.
I'm a first alum, so a lot of what brings me back is like, I keep a little version of my 17-year-old self in the back of my brain and keep asking him, like, what would you want if you know, and he keeps telling me that first is the best thing he's ever seen. And so to me, that means I should be helping provide those opportunities for students however I can. So if I can be there to unlock the door and turn on the lights and let a bunch of kids have fun with what they're working on at first, that's it for me.
Well, unfortunately, I just saw our timekeeper at the door. We're kind of out of time. Ryan, Ramon, Steve, David, Alvin, Luann, thank you so much for your time today. It's appreciated.